Hello everyone, welcome to Talk Mathematics. So this is the third video of class 11 Maths NCERT solutions of chapter 1 sets. So today we will be discussing some examples of exercise 1.2 and exercise 1.2 solutions. So let us start by some basic definitions. The first one is empty set. So for example, if I tell you to make a set A, that is apples that are blue in color, so your set will look like this. It will be empty because there are no apples that are blue in color. So by definition we can say an empty set is a set containing no elements. Let us consider another examples if of set B mathematically, which says that x such that x belongs to natural number, x square should be greater than 40 and x should be less than 5. So can you find a set like this that whose square is greater than 40 but the number is less than 5? So we cannot find any natural number like this. So this set will also be an empty set. Another representation of empty set is phi. This symbol is called phi. This is a representation of empty set. Empty set is also known by some other names as well, like void set, or it is also called null set. Right, so these two are the examples and this is the representation of empty set. So next up we have the definition of finite sets. Finite sets, as the name suggests, these are the sets which have fixed number of elements, or the number of elements you can count. Fixed number of elements and you can count those, you can state those. So let me give you an example. The first example could be construct a set X such that the students of your class, the names of the students of your class. So you can clearly state the students of your class. This set would be finite. Let us consider another example mathematically, which says that this sets contain all those x such that x belongs to natural number and x square is less than 40. So you can clearly state those natural numbers. This set would look like 1, 2, 3, 4, 5 and 6. So this is a finite set. Now another topic is infinite set. So what are these sets? Which are infinite, you cannot count them and you don't know where they will end. For example, let us construct a P set which state this is a set of all points on a line. So you know that this is a line. So how many points are there on this line? This point, this point. There are infinitely many points on this line. You cannot write it in the form of a set, nor these elements would be finite. You cannot count them. So these are infinite. Another set could be the set of all natural numbers. These are infinite, they go on and on. The set of integers, the set of positive integers, all these sets are infinite sets. Another one is equal sets. So what are equal sets? Two sets are called equal when they have exactly the same elements in both of them. For example, there is a set A which consists of 1, 2, 3 and 4, and there is a set B which consists of 4, 2, 3 and 1. So these both have same elements. 1 is here also and here also, 2 is here, 2 is here, 3 and 4. Exactly the same. So here we can say that A and B are equal sets. Or writing it mathematically, we can write as A is equal to B. Another example, if I take a set P mathematically, if I say that it consists of all those x such that x belongs to natural number and x is a prime number less than 6. So how this set will look like? This set will look like 2, 3 and 5, a natural number and a prime also. And if I say another element Q, which is such that it contains all the prime factors of 30. So you know that all the prime factors of 30 set will look like 2, 3 and 5. So as you can see, these both the set consist of exactly the same elements. So here P and Q are equal sets. So that's all for some of the basics that you just need for solving all the examples as well as exercise 1.2. So look at this example 6. The first example that is related to exercise 1.2. It states that which of the following sets are finite or infinite. We need to tell this. So first part says that x should be a natural number and x minus 1 and x minus 2 should be equal to 0. So this set will consist of only two elements, 1 and 2. After solving this, x value will be 1 and x value can be 2 also. So only two elements, so this will be a finite set. Another one is x belongs to natural number and x square should be exactly equal to 4. So this set will contain also two elements, 2 and minus 2. And this is minus 2 will not come here because x should be a natural number. So this set will only have 2 in it, and this is also a finite set. Next up we have x should be a natural number and 2x minus 1 should be equal to 0. And you can see that it would be empty because x value will be 1 upon 2 and 1 upon 2 is not a natural number. So what will be there in this set? It will be an empty set. An empty set is also finite. Fourth part says that x should be a natural number and x should be prime also. So this set, how will we look like? Prime numbers we have to state. It will be 2, 3, 5, 7 and this set will go on and on. We don't know where it will stop, and all these are natural numbers. So this set would be infinite. Next up we have x is a natural number and x is odd. So all odd natural numbers will be 1, 3, 5, 7, 9 and it will go on. We don't know where it will stop. So this is also a infinite set. Next up we have the example 7 which states that find the pairs of equal sets. So equal, we need to find the equal sets. So we can clearly state all the sets. A set is clearly visible. It contains only 0 element. What is a B set? B set says that x should be greater than 15 and x should be less than 5. Greater than 15 as well as less than 5. There is no number like this. So this set is empty. Or you can also use the symbol phi here. C set is x minus 5 should be equal to 0. So C set contains only one element, which is 5. D set says that x square should be 25. So we know that 25 square is from 5 square and minus 5 as well. Then E says that x is an integral positive root of this equation. So let us solve this equation using splitting the middle term. So we have to make the factors of 15. So it will be minus 5x plus 3x minus 15 is equals to 0. We take common x and plus 3. And then we can pair x plus 3 and x minus 5. And x value is coming out to be negative of 3 and positive of 5. And this set should contain only positive roots. So E set will look like only 5. 3 minus 3 will not be here because we have to consider only positive ones. So how many pairs are equal? So clearly you can see only C is equal to E because C has also one element 5 and E also. So exactly C is equal to E. Next again we have to find that which of the following pairs of sets are equal. So first part we have X, the set of letters which contains alloy. So let us start by writing A. L we will not repeat it, then O and Y. And how the set B looks like? B looks like the set of letters in the word loyal. So it looks like L, O, Y and A. And you can see the X and B are exactly equal, the same number of elements. So yes, X is equal to B and they both are equal sets. Second part, let us write the set A, which states that here is a variable n and n belongs to integers such that n square should be less than equal to 4. So we have n square should be less than equal to 4, n should be less than equal to root 4, which is n should be less than equal to plus minus 2. Means n value is between minus 2 and plus 2 and n should be an integer. So all the integers between minus 2 and 2 are -2, -1, 0, 1 and 2. Let us see now B set. B set is x should be a real number and x should be the solution of x square minus 3x plus 2. So let us find its solution by solving this equation. We have to make the factors of 2. So we are writing as -2 and minus x. We take common -1. We have now two roots as x minus 1 and x minus 2. The x values are 1 and 2. So B set will contain 1 and 2. So A set have 5 elements in it, -2, -1, 0 also. But -2, -1 are not here. So A is not equal to B. These not are equal sets. Next up we have which of the following are examples of null set. Means we have to find which of them are empty sets. So the first one is set of odd natural numbers divisible by 2. So we know that natural numbers are beginning from 1, 1, 2, 3, 4, 5, 6 and which are odd will begin from 1, 3, 5, 7 like this, and none of them is divisible by 2. So this set would be 5, means empty set. It will be null set. Next is set of even prime numbers. So we know that prime numbers are 2, 3, 5, 7 and we know that even number which is prime we have one number as 2 which is even also and prime also. So this is not empty. We have one element 2 here. Next is x should be a natural number and x should be less than 5 and greater than 7. So one number which is both less than 5 also and greater than 7 also, there is no such number. So this is a null set. Next up is y is a point common to any two parallel lines. So we know that two parallel lines have no point in common. So this will also be a empty set. Only the second part is not a null set. Rest all 1, 3 and 4 are null sets. Second question is which of the following sets are finite or infinite? So the first one is the set of months of a year. So we know that the months of the year you can count and write it as well. So this set is a finite set. Next is this set 1, 2, 3 and this set goes on and on. We don't know where it stops. So it would be infinite. Next is 1, 2, 3 and we know where this stops. It will be 99 and then 100. At 100 it stops. So we can easily count the elements as well as write the elements here. So it would be a finite set. Fourth is the set of positive integers greater than 100. So all the positive integers greater than 100 would be 101, 102 and all those elements we don't know where it will stop. So this is a infinite set. Next up, fifth part, we have the set of prime numbers less than 99. You can write the set like this 2, 3, 5 and so on, and you can also stop. You know where to stop. We have to stop at a number which is less than 99 and a prime number as well. So we have the stopping condition here. You can write it. So this would be a finite set. So first, third and fifth are finite. 2 and 4 are infinite. So the third question states that which of the following is finite or infinite. The first part is the set of lines which are parallel to x-axis. So we know that this is the x-axis and there are infinite lines which could be parallel to x-axis. So this set is infinite. Next up we have the set of letters in the English alphabet. You know that you can easily state that A, B, C, D like this and you know where to stop. So this set you can easily write. So this is a finite set. Next up we have the set of numbers which are multiple of 5. So the numbers which are multiple of 5 would be 5, 10, 15 and this set goes on and on. You don't know where you have to stop. So this set would be infinite. Next up we have the set of animals living on the earth. So there are only fixed number of animals which are living on earth. You can easily write the names. So this set would be finite. Next is the set of circles passing through the origin. So you know that this is the origin 0, 0. So how many circles could pass through it? There are you can construct infinite circles. So this set would be infinite. Now let us come to the fourth question which states that state whether A is equal to B or not. So first part in A we have A, B, C and D, and exactly A, B, C and D we have in B also. So this, yes, they are equal. Second part, we have 4 here also, 8, we have 8 here also, but we have 12 here and 12 is not present in B. So these set could be cannot be equal, so these are not equal. Third part, we have A set is 2, 4, 6, 8 and 10. B set is x should be a positive even integer and x should be less than equal to 10. So we have to construct the set which has even integer and a positive also. So this set will look like 2, 4, 6, 8 and 10 also. We have to include 10 because there is an equality sign. So now you can match your A and B set which is exactly same. So these are equal. Fourth part, A is a set which is a multiple of 10. So we have 10, 20, 30 and this set goes on and on. This is an infinite set. And for B, we have this 10, 15, 20, 25 and this set goes on and on. So here 15 is present but 15 is not present here. So these set cannot be equal. Again we have a fifth question which says that again we have to find which of the sets are equal. So first part, we have A is a set of 2, 3 and B is a solution of this equation. So let us find its solution. For solution, we can solve this equation by splitting the middle term. X square plus 5x plus 6 equals 0. We have to make the factors of 6. So this it will be 2 and 3 plus 6 equals 0. Taking the common, we have x plus 2 plus 3 and x plus 2. So x value would be minus 3 and minus 2. So this set B set will look like minus 2 comma minus 3. But A set is positive 2 and positive 3. So this set are not equal. Second part, we have x should be a letter in the word follow. So how this set will look like? This will contain an F, O, L and W. We will not repeat. And B set will consist of W, O, L and F. So when you will compare these two, these have exactly same elements. So A and B are equal. Sixth question, from the sets given below, select the equal sets. So we have to find the equal sets. So A set is 2, 4, 8 and 12. So can you find any other set which consists of exactly 2, 4, 8 and 12? No, there is no such set. Now come to B part. B says that it contains 1, 2, 3 and 4. So can you find a set which contains exactly 1, 2, 3 and 4? Yes, we can find a D set here. It also contains 1, 2, 3 and 4, exactly the same. So we have found one pair, that B is equal to D. C is 4, 8, 12 and 14. So can you see any other set similar to this? No. E part is minus 1 and 1. So can you see any other which contains exactly 1 and minus 1, which is G. So another pair is E and G. D is done, E is done. Now F, 0 and element A. Here we do not have 0 and element A. Here we have 0 and 1, but here A is there and here 1 is there. So these are not equal. So in sixth question, only two pairs we can find of equal sets, which are B is equal to D and E is equal to G. Thank you. Let us now do exercise 1.3 in next video.